So we continue to lecture 3. Now we analyze this physical model. Okay, we have the mass of a car M. Okay, and the phase angle, the inclined angle theta. Okay, so such question A, find the acceleration of the car. Okay, assuming the triways is frictionless. Okay, that means the surface has no friction. Okay, so if we consider this one, you can know the moving direction of the car, right? The moving direction of the car is like this, right? Okay, so that's the reasons we choose the reference axis. Okay, like this a x, this a y. Okay, and then we only have ax, we have no ay or ay is 0, right? Understand? Because x-axis component is similar to the moving direction. Okay, the moving direction will be similar to the acceleration. Okay, so if we choose the coordinate like this, x and y, okay, so we only have ix. Okay, we can skip ay or ay 0, but it's random, you know. So if you choose this one is x and this one is y, that's okay. But now this one is vector A, and we need to analyze we have ix and we have ay. So now, you know, your solutions will be complicated because we need to consider two components of ix and ay. Okay, don't use it. Okay, don't do that because for the final exam you don't have more times. Okay, much more time to make the physical model to be complicated. Is it clear? Okay, so you try to make as simple as possible. Okay, so that is the reason we choose xy like this. Okay, and then we just consider ix, we skip ay or ay 0. Do you understand? Yeah. So now this is moving direction. This one is x, this one is y. So now you know the model will be more simply. Okay, so we have gravitational force. Okay, we have no external force. Okay, so we only have gravitational force Fg. Okay, and then this is x-axis, right? This is y-axis. So you get Fx and Fy. Okay, Fgx, and then Fgy. Okay, so this one is theta. So this one is theta. This is theta, mean this one theta, right? Right? Okay? Yes? Very easy, right? Okay, so for here you get theta, so we can get y-axis components of fg's. This is theta. This could, if you times cosine theta, you can get fgy. Okay, and then if you times sine theta, you can get fgx. Okay, and here we have the surface, so we have normal force. Okay, remember that normal force is always perpendicular to the surface. Okay, this is the surface, so and should be the normal force must be like this, you know. Yeah, the normal force is always perpendicular to the surface. Okay, so now we get vectors diagram, force diagram. Okay, and then you can formulate the vector diagrams into some equation. Okay, so now we have Fx total. Okay, is what? Here, you know, here, this is x, this is ax. Okay, so you can get mg psi theta. What else? That's all. Okay, equal to what? M AX. Right? Because the second law we talk about FE, M times A. Okay, so if Fx you have AX, Fy we have M, AY. Is it clear? Okay, so here for XS is component, you get IX. So now we have, we need to delete. We need to delete the vector. So Fy total is what? Is N, right? N is similar to YS in direction, minus what? Minus mg cosine theta E M AY. Okay, like I mentioned before, because AXE in parallel with x-axis, so AY will be 0. Okay, so remember that we choose the x-axis E similar to the moving direction. Okay, you only have AX, no AY. Okay, so that means you get 0. Yeah, and we combine 1 and 2, you can get AXE G sine theta. That's all. You understand? Yeah. Okay. Just think about the physical model. I mean, more simply. Okay. Because if you choose another reference coordinate, okay, maybe you make more times to get the answers. Okay. So for such question B, suppose the car is released from the rest at the top of the incline, and the distance from the car front bumper to the bottom of the incline is D. So we have the formulas. Anyway, we can see here at the top, okay, and we need to calculate the distance. Okay, how long does it take the front bumper to reach the bottom of the hill? Okay, over here. Okay, theta, the car here. Okay, and what is the car speed when it's arrives there? Okay, yeah. So now we can, we can think about constant velocity or constant acceleration model we have studied from lecture 2, right? So this is initial position, and this is the final position, right? The final position. Look, define the initial position, okay, of the wrong bumpers. A is xi is 0, and the final position xfd. So you can get the ly x like this. This is y, this is x, this is origin, right? And this one is ix, right? And ay is 0. Do you read me? Okay, so if here this is xi is 0, and then here you can guess xf is d, the distance, right? Okay, right? D, yes. Okay, so x is constant. Okay, x is constant, so we can apply constant acceleration. Okay, how many formula we studied before? 1, 2, 3, 4, 5. 5 important formulas, right? Okay, so they ask us to determine xf. Okay, so we can use these formulas. So we have xf is xi plus vxi plus 1/2 axt squared. Okay, xi is 0. Okay, at the beginning vxi is 0, so you can get this one. So you can get this is half axt squared. Okay. Yeah. So why ax is constant? Why is x constant? Because mg is constant. Okay, and the theta is constant. So we only have 1/4 mg sine theta. This is constant. So f constant, m constant, mass constant. So ax must be constant. Okay, so so we know. Okay, we have under constant acceleration models. Yeah, and then we continue to calculate how long time. Okay, so we can calculate time. So time is the square root of 2d ax. So if we know d, we can get you can get the times. Okay, so times is blah blah. Okay, yeah. And we also calculate the final velocities of the car. Our position is 0. Okay, xi is 0. So you get vxf square is 2ax times d. Okay, after that you can get final velocities. Okay, so the car speed is calculated by this one. Okay, so remember that we only have two cases when we analyze any physical model. The first one is constant velocity model, and the second one is constant acceleration models. Okay, yeah. Any questions so far? Yeah. If you don't understand, ask me. Okay, don't be shy. I will explain to you again. Okay. I will be here to help you. Okay. So if you don't understand, ask me. I will explain to you. Female students, any questions? Questions? Okay. Or you can ask Mr. Hua. Okay. He is this excellent student. Okay. Yeah. So one more example. 5 minutes. Okay. You need to analyze the Fox diagram. Okay, yeah, sometimes we say Fox diagram, sometimes we say vector diagrams. Okay, that's okay. Yeah. We have two blocks, okay, M1 and M2, okay, with the mass M1 and M2. Okay, we have a constant horizontal force F, okay, imparting on the object M1. Okay, so find the magnitude of the acceleration of the system, yeah. So you can know the moving direction, right? So the moving directions of these objects is this, right? So this one ax. To have ay, no, ay will be 0. Okay, yeah. So if we carefully consider the moving directions, we should choose coordinate systems like this, right? X, Y. Yeah, and x-axis is similar to the moving direction. Of course, you can choose x, y like this, but you are stupid, because you make the questions, okay, more complexity, more complicated. Okay, so please don't do that. Okay, I know you are very talented, but don't do that for the final exam. Okay, yeah. So that is the reasons we have the coordinate system like this. Okay. So if we pick up M1 to analyze the force, we have normal force come from object 1. We have gravitational force. We have F, F. Yeah, and we have another force B21. Why we have B21? Because we have the force, okay, from object 1 to object 2, which is B21. Okay, sorry, from object 2 to object 1, which is B21. And we also have another force from object 1 into object 2. Okay, so object 1 into object 2 like this. Okay, B12, and the force from object 2 into object 1, you get this one, B21. Of course, okay, the magnitude of both vectors will be equal. Okay, so that means when we combine object one, object two, you can delete this one and you can delete this one, right? Okay, yeah, and we have the normal force of object two, and anyway, yeah, yeah. After that, we can formulate, okay, this vector diagrams. Okay, so we have now, if we consider object one, we have fy is what? Fy total is what? N1 minus M1, which is equal to 0. And fx total is what? E f minus B21 E M1 AX. Do you agree with me? Okay, so if we consider object 2, we have what? My total is what? N2 minus M2 is 0. And we have fx totals is what? B12. Okay, equal to what? M2A AX, you know. Both of them have the same acceleration AX. Do you read me? Okay, so when we combine, so we say equation 1, equation 2, equation 3, and equation 4. So when we combine, we have 2 plus 4. Okay, so 2 plus 4, you get what? You get f, okay, this one equal to this one, so this is minus, so we delete. You get fe m1 plus m2 ax, right? So then, bệnh cũ tái phát, nói chuyện nữa. Còn nào mới lại nhảy nó hoài vậy? Tách ra đây. Mấy nào ngồi cặp này, tách ra. Mỗi thằng ngồi ghế, cách phải bỏ ghế. Sao cái bệnh muốn nói chuyện này muôn thở chứ nha. Mới dạy nó một cái bài học về đạo đức xong cứ nói chuyện nữa. Kinh khủng thiệt. Thế giới Gen Z bây giờ ghê gớm quá. Cách đây 16 năm về trước, mười mấy năm để coi. Học đại học năm 2004, năm nay 2026 rồi. Cách đây 21 năm về trước, khi thầy bắt đầu học đại học, 108 thằng, 2 bạn nữ vô lớp im re không một tiếng động. Mà hồi xưa mà mấy đứa biết đâu có máy lạnh gì đâu, có mấy cái quạt trần đó. Mà mấy đứa cái thời xưa thì 20 năm về trước cái quạt trần là mấy khủng khiếp lắm. Nó quạt một cái là cốt két hì nó kêu như là mày chỉ cần nói chuyện nữa là không có nghe được gì hết. Hồi xưa học một cái thầy mà nói chuyện lặng quạng thầy đuổi học. Mà các em biết mà rớt lần đầu và thi lần 2 nó khó gấp bội lần thứ nhất. Cho nên là hồi xưa học lưu ba nhiều lắm. Mà rớt lần thứ 2 rồi lần thứ 3 là khó dữ hơn nữa. Giờ hỏi ba mẹ coi xưa học đại học nữa. Bây giờ sướng ngồi máy lạnh ngồi nghe không chịu nghe nữa. Rồi 2 năm tiếp theo bắt đầu nó gặp thầy để tư vấn tâm lý, rất nhiều quá tư vấn. Vừa rồi bây giờ các bạn biết có một cái anh đã rớt 16 môn, gặp thầy để tư vấn tâm lý rồi phải nhờ giúp đỡ, hỏi anh Bảo Thanh và giúp đỡ đến bây giờ mà còn nợ 6 môn là biết là khủng khiếp rồi, trả nợ 16 môn trả nợ còn. Đừng có đến gặp tôi mà tư vấn tâm lý nữa, tôi mệt lắm. 16 môn là mấy đứa tính cây rớt bao nhiêu học kỳ hả? Gần 4 một kỳ, khủng khiếp không? Đúng không? Đấy. mà thầy cứu rồi thầy cứu, thầy dìu dắt, thầy giúp đỡ, thầy ôn luyện nhờ các anh khóa trước ôn luyện, bây giờ còn lại cái 5 môn là thấy một sự nỗ lực kinh khủng. Okay, so yeah, we just share with some students about the story. Okay, so some students failed many courses. Okay, but after he meet me for advice, and up to now he just fails a few courses. Okay, yeah, from 16 failed course now just 5 courses. Okay, he put a lot of efforts to pass the course in ECE program. And I don't want to give you any advice if you fail for the course, like him. Okay, you know, don't see me to get any advice how to pass the course. Okay, so if you fail physics 1, you need to ask for yourself, okay, whether you are stupid or not, whether you are lazy or not. Okay, you know, we have some student ECE 2020, ECE 2021 who failed this course, you know. So we can guess AX is F, right? Divided by M1 plus M2, right? Very easy. So this question be determined the magnitude of the contact force between the 2 blocks. Okay. That means we need to calculate B12 and B21. So we just calculate 1 because we know B12 is B21, right? B21. Okay. Yeah. So we can guess if we consider object 2, we can get B120 will be calculated by these formulas. Okay. And if we consider equation 4, you can get B12 is also calculated by this one. The same, you know, it's up to you. And if we know B12, you can get B21 because the magnitude of them two will be equal. Okay. So one more example. 5 minutes. Try to understand it. A person weighs a fish of mass m on a spring scale, okay, attached to the ceilings of an elevator, okay, like this one. But for the left figures, the elevators, okay, accelerate upward, and here downward. So the spring scale reaches a value greater than the weight of the fish. And here, you know, the spring scales reach a value less than the weight of the fish. Yeah. And you need to analyze why. Okay. Why? So for here, we consider the left figure first. We can choose this is y, this is x, right? Right. Because the movings of the horn object here is going up, right? So we try to select y-axis to be parallel with acceleration vector. Okay, so we only have ay and ax will be 0. Okay, remember that. Do you read me? Yes. Okay, I hope so. So now we can get, so we only have total force, okay? Is, we have tension force, okay? Tension force T minus mg, okay, equal to m ay, right? Ay is positive, right? Because acceleration is in parallel with y-axis, okay? So, and then you can get the tension, okay, tension. So you get tension force is Fg Ay plus divided by G plus 1. Okay. So this one higher than 1, right? Actually, for this fix, you get Fg. Fg is M times G, right? But now we get Fg times 1 plus Ay, of which Ay is positive. Okay, G is positive, so this one is positive. So 1 plus positive value, you get this one higher than 1. So that means you get more tensions, more weight. Do you read me? So if you think this one, you can see Ay is negative. Ay negative. That's right? So Ay is negative, so this one is negative. Okay? Of course, less than 1. Okay, this one is less than 1, right? Because 1 minus some things. So we get the values less than 1, so that means you get less than tension. Okay, less than weight. Do you understand? Yeah. Any questions so far? And of course, we have some calculations. Okay, so for upward, you can get the tension force is 48.2 because Ay is positive. So for downward, we get tension force is 31.8 because Ay was negative. Okay. Yeah. So the key point is here, explanation here. Okay, this scalability is greater than the physical weight mg because H is upward, so Hy is positive. Otherwise, Hy is negative. So you get this one. The weight is less than the original weight of the fish. Okay. Any questions? Okay. So no questions. Continue. Oh, example. 5 minutes. Think about these questions, okay? So the questions ask us to determine the magnitude of the acceleration. The magnitude of the acceleration of the two objects, okay? And the tension in the lightweight string, okay? Yeah. Okay, so we need to answer this this question.